Welcome to another episode of Brewing with the Elder.
Okay, so welcome back, adventurers. It's been several weeks now since I saw you last. I hope the village of the 8th Heroine has been treating you well. So, we've got the invisible spirits right here. We have what is, as I have said multiple times before, a wort. And inside of here was our sugar and our yeast, with some enzymes called amylase to help break the sugars down and basically allow the yeast to do their action a little bit more quickly for us. So, in here now, as you can see, this entire jug is a bunch of murky water. And before it was crystal clear, you could see right through it. So it lets you know how many microbes are now living inside of here. They've multiplied exponentially. And inside of here we have alcohol, or what I like to call invisible spirits. The problem is, it's only probably about 3 or 4%, so there's not a lot of it in here. And that's just not very useful. So, we have to do a particular technique called distillation, and that's what I'm going to show you next. So, get one last look at your wort here, because we're going to turn this into pure invisible spirits. Just you wait. Okay, so as you can see here, I've put in our rum beer, our sugar beer right here inside of this volumetric flask. Now it's being heated by this ceramic heater here. It's an electric ceramic heater. It's slowly bringing the temperature up inside this volumetric flask to where we want it, which is about 173-ish degrees Fahrenheit. And the reason we want that is because ethanol, the invisible spirits, they evaporate at 173 degrees. Now, water, if you remember, evaporates at 212 degrees Fahrenheit. So if we can get this just above 170 degrees, the water stays behind and the invisible spirits make their way up this tube and into the smaller volumetric flask here. Now, this tube here is a very special tube. If you look closely, there's actually two tubes here. There's a single tube in the very middle of this that connects this volumetric flask with that one. But then there's a tube surrounding that. And there we have water running around the outside of where the ethanol is going through. And there's a reason for that. Now the water comes out of here and flows off into the drain, so it doesn't cause us any issues. Now, the reason we want to run water over this is because water's a squirrely molecule, and it likes to evaporate at temperatures it's not supposed to. So even if we get this to 173 degrees exactly, we're still going to get some water coming up the tube and into the other volumetric flask. So, the water that flows through the outside coil is there to help cool down any water vapor as it heads up the tube. Now, things to mention about this. Even if we go through and we get this perfectly, we will have to run this condensed or distilled spirit back through the process once more if we're going to have concentrated spirits. And that's what we want to do. So we're going to run this process 2 times to get where we want to be in the percent of alcohol. So stick tight. This is going to take a while. As you can see here, we have collected our invisible spirits, our ethanol. And what we have left behind here is just dead yeast now because they've been boiled, remaining sugars, and a little bit of ethanol, not much. So this is mainly just water, and we need to dump this in just a moment. This here is our distilled spirits. Now, as I said before, the first time through, we maybe only have 20%, so we have to run this through one more time. And that's what we're going to do next. Alright, now there you have it. Pure invisible spirits. Maybe as high as 60%. You can set this stuff on fire. You can make a big boom. You can even peel the paint off your house if you really need to. I don't know why you'd want to do that, but if you need to, you can totally use that for that reason. Anyway, so here you go. This is how you make the invisible spirits. With water and sugar and yeast. That's really all you needed the whole time. You're just laying around your house, you had no idea. You had to come all the way out here for me just to show you what to do with stuff you already had. But anyways, don't believe me. Let's go on ahead and put this stuff to the test. And if you make it pure enough, kids, well, watch this. See, there's the flame. Fire. So, if you do it twice, you get it high enough to make fire. Beautiful. You make biofuels, fire your house, whatever. I don't know. There you go. Okay, so now you know the secrets of the invisible spirits. You just needed stuff you already had at the Mages College. So, you know, you've been here for several weeks now, watching it all ferment and going through the whole process, so, it's getting kind of late, don't you think? Long trip back to the Mages College. You should move along now. I'm tired of you staying at my house. If you've overstayed your welcome. You've been eating up all my food. To be honest with you, it's getting on my nerves. So, tell the Archmage I said hi, and go on. No, go on. Move. Get out of here. Leave my property now.
So let's go on ahead and review what the village elder just covered. So you guys are learning about fractional distillation. And all that means is that we are breaking apart two different liquids and trying to separate them out. Because as you know, it's very difficult. Once you mix Kool-Aid together, you can't really get the Kool-Aid dye out or the flavoring out. It's now been mixed. So you got to do something else in order to separate the things that you want. In this case, in our rum beer that we made, there's sugar and water and ethanol and yeast, and really all we want is the ethanol, the invisible spirit, right? So we have to use this process of fractional distillation. And you can see here on the photo, we used to use Bunsen burners, which are little gas burners. So we actually used to use fire, but we heat the beer until it's about 180 degrees. And once it's about 180 degrees, you start boiling off more water than ethanol. Water is always going to kind of boil off. If you notice, even on a hot day, if you take a glass of water and stick it outside, a lot of it will evaporate just from the sunlight and the atmospheric pressure. So water is a weird molecule, and the more energy you add to it, the more of it kind of evaporates off on its own. But technically, the evaporation point, or the boiling point for water, is supposed to be 212 degrees Fahrenheit, while ethanol is 173 degrees Fahrenheit. So if we kind of shoot for about 180 degrees, we speed up the process of the distillation a little bit. We'll get a little additional water, but that is what that condenser coil is for. It's to help, uh, it's to help uh, gravity essentially and condensation pull the water back down into the beer, while the ethanol, which can be, if it's 190 or 180 degrees floating up into that tube to go into the other side, well, even though it's being cooled, it's still above its condensation point, above its boiling point. So it will make its way as it's being cooled up to the next flask. And then as it hits that little corner, it condenses at the top and then drips down in. And you can kind of see that in the photo here. So the condenser coil there, again, is just simply to cool both the water and the ethanol vapor. The water condenses and drips back out, and the ethanol just cools down. So when it hits that corner there, and I'm pointing to it right here, the corner little tube there, that connector, then it starts to condense down into liquid ethanol again once it goes back below 173 degrees Fahrenheit. If you don't have that condenser tube and you do this very quickly, you can build up a lot of pressure, and it causes issues. We'll just put it that way. Don't want to go on too long of a rant here. So I wanted to bring this up really quick. Fractional distillation is actually how we turn oil into all of the different products like gasoline, diesel fuel, oil that you use in your car, the tarry stuff that we use to make road, the bitumen is what it's called. This same exact process is how we refine oil into all of the multitudes of different products that we get from it. And if you look at the little photo here on the right, with the tower and like the car and all of that stuff, it shows you the boiling point, so to speak, for each of these different molecules located inside of the oil. Because crude oil is like a mixture of all of these different things from, well, you can see on the thing, from everything from gasoline, kerosene, all of those things. So they're all kind of mixed up. And if we heat them up, well, each one of those chemicals, each one of those molecules, different molecules, has different boiling points. And if we have a big tower like this that can, collect them at their different boiling points, we can separate them out. We can tease them out. And then we can use that more pure product as opposed to a big, stinky, nasty oil, which isn't as useful. So this is a really important process, fractional distillation, and that's actually why you guys are learning how to do it. This is real science. Like, this is stuff that people do all over the planet to make some very, very important products for us. I mentioned in the video that you have to go through, if you want to have fuel grade ethanol, you have to run this process twice. That's just because our particular setup, while it's effective, it's not going to get you up into the high percentages after only one distillation, because water is still kind of coming through the tube, even though we're doing everything we can to keep it from happening. So that first set of liquid that you get is only probably 20 or 30% alcohol, and that means it's 80 to 70% water. So you've purified it in terms of, like, there's no sugar in there, there's no yeast in there. So it's now just ethanol and water, but it's not pure liquid spirit. It's not pure ethanol yet. So you have to run the process back over again. So you dump out your beer, you add your newly distilled, we'll call it solution, and then you boil it again at the same temperature. This time you can, keep it around 175, a little bit lower, and run it through the distillation process again. And by the time you get there, you'll be approximately 40 to 60% ethanol, depending on how good of a job you've been doing, what type of condenser coil you have, how well you kept the temperature steady. There's a lot of different variables, okay? Because as you start to run out of liquid on the one side, it takes less heat for you to heat it up. So you have to continually turn the temperature down without dropping it. You get the point. It's a skill. So once you get to 40 to 60%, now you actually have fuel grade ethanol. You can actually burn it. So that's what that lighter test was me just pouring it out to show you, hey, we're pure enough on the ethanol now, it can be used to burn things, it can be used as a solvent, which is what alcohol is used for a lot, as a solvent. You use it to dissolve things, right? It's great at breaking down oils. So we use it to, I mean, hey, think of the expo markers. The reason they smell like alcohol is because they have alcohol in them. It evaporates, but it keeps the little pigments, the stuff that we actually write on the board with, the color, it keeps it dissolved in a solution, and then you wipe it on the board, and then the alcohol goes away and it leaves the solid color behind, your marker behind. So we use ethanol for all sorts of reasons, and it's partly because it's a solvent. It's a really good solvent, and it evaporates away cleanly. So that is the process of fractional distillation. I hope this intrigued you. Again, sorry we couldn't do it in class. I totally had it planned. But yeah, here's a really useful, cool scientific process. You can order all of this stuff yourself. There's all sorts of different home brewing things online. So if you really like the idea of making your own like biofuel to power your own, not electric scooter, like motorized scooter or whatever, this is a cool process. So yeah, that's fractional distillation. I hope you enjoyed watching this video. I know we couldn't actually do it together. Pandemic kind of got in the way, but hopefully this little instructional video is good enough to kind of give you an idea of how this is done. And hey, I mean, this is a real skill, this is a real career, and this is a big career. This is all over the United States and all over the planet. Like, we need fractional distillation as a process, and people who understand it and can do it, because we use it for so many products, so many of your products. I can't go into how I can't express how important solvents and just like things that come from crude oil and all of that. So much of chemistry has fractional distillation to thank, because that's where we get a lot of our raw materials from. So anywho, hope you enjoy this. Till next time.